Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. And in this video lecture we will study the concept that is multiplication of matrices. So we will see that how we multiply the given two matrices. Okay. Let us suppose that we are given a matrix, say 1, 2, 3, 1. So what is its order? It has 1 and 2, 2 row, 1 and 2, 2 column. So its order is 2 by 2. So if we have to find that which rules we should govern, so we should look at its rows and columns. It has 2 rows and 2 columns. So if we multiply it with any element, then make sure that it should have number of rows equal to 2, means its column. The following element, whichever following matrix whichever you take, should have the number of rows equal to 2. Like we have 1, 1, 2, 1, 2, 1. So it has 1 and 2 rows and 3 column, 1, 2 and 3. So which rule is to be checked, or is to be make sure whether it is followed or not? The number of column this matrix has, it has 2 columns, that is 2 columns, must be equal to number of rows this second matrix has. It has 2 rows. So if I say that number of columns of, and say this is A matrix and this is B matrix, number of columns of A matrix is equal to number of rows of B matrix. Fine. So this should be governed. Only then we can multiply. Now this can be multiplied. If instead of this here we would have written 1, 2, 3, 1. Okay, it is of 2 by 2 order. And here we would have written like 1, 1, 2, 1, 2, 1, 1, 0, 0. So it is having 3 rows and 3 columns. So here the number of columns in this are 2 and number of rows in this are 3, and we know 2 is not equal to 3. So if we take this A and this as B, so multiplication is not possible. Is not possible. Fine. So in this case multiplication is not possible. But here in this case multiplication is possible, and we will be multiplying. And which rule we should follow while multiplying them? Look at it. We will move from here and multiply it with the first row is multiplied with the first column, and the resultant matrix will be of order 2 by 3. Resultant matrix will have 2 rows and 3 columns. So whatever matrix we'll get, we will be having two rows and 3 columns. So I have kept enough space so that I could write the calculations also. So the resultant matrix will be order of 2 by 3, because 2 and 2 both are equal, so resultant will be 2 first and this last 3. Now multiply first row with first column. 1 into 1, 2 into 1 plus sign. This is the first entry. Now this second entry of the first row and second column, this entry will be first row, this entry will be first row, second column. So this is first row will be multiplied with the second column, because we are saying that it is a second column. So multiply it with the second column. So 1 into 1, 2 into 2. Now fine. Next is this entry, because it will be having 3 column. So this entry will be first row and third column. Fine. So first row is multiplied with the third column. So what is the third column? This is the third column. So I am going to write it as third column. This is third column. Fine. So multiply 1 into 2, 2 into 1 plus 2 into 1. Fine. Now we will operate the second row with each and every column. So let us say this is second row and we will operate it with each and every column. So first operate this blue row with green column, that is first column. So what it will be? 3 into 1, 1 into 1. So 3 into 1 plus 1 into 1. Fine. Now this green second row, this blue row will be operated with this second column. So it will be 3 into 1, 1 into 2. Fine. Now next this row will be operated with this pink color column. 3 into 2 plus 1 into 1. So now this can be easily solved, and this will be equal to 1 1 is 1 plus 2 is 3. Fine. 1 1, it will be 2 2 is 4 plus 1 is 5. 2 plus 2 is 4. 3 plus 1 is 4. 3 plus 2 is 5. 6 plus 1 is 7. So this is 2 into 3 order. So that is how we multiply, and order is 2, because it, and you can see it has 2 rows and 3 columns. So the important thing that we must check before doing the multiplication, we check whether the matrices are compatible or not. And how do we check the compatibility? By checking the number of columns of the first matrix and number of the rows of the second matrix. Both should be equal. If both are equal, then they can be multiplied, otherwise they can't be multiplied. If A is multiplied with B, so the result is AB. And one more thing that we must go on, that we must see here, that AB need not to be equal to BA. So commutativity, this property is called commutativity. AB is equal to BA is called commutative, but matrix multiplication is not commutative. Fine. So you can take any example, but in this case if we will put B over here, and if we put B first, order of B is 2 by 3 and A at second place, order of A is 2 by 2. So here it is 3, it is 2, so both are not equal. In this case, this product B, when you place it first and A place it second, this multiplication is not valid, because number of columns in B is not equal to number of rows in A. So BA does not exist. Okay, so similarly you can do other examples also. So we will take one example, and in that example we will show that it is not necessary that AB is equal to BA. Sometime AB is not equal to BA, and that is if we even get a single counter example that shows that AB is not equal to BA, so that property does not hold good. So commutativity property does not hold good in matrix multiplication. We will see by another example. So I am taking the example here. The example is, so we have taken A as 1 by 3 order matrix and B as 3 by 1 order matrix, and simple entries are taken 1, 2, 3. So we will try to calculate AB. Firstly we shall check whether it is defined or not. First write 1, 2, 3. Okay, and this is of 1 by 3 order. Next write B 1, 2, 3 and write its order 3 by 1. So now we see number of columns of A are equal to number of rows in B. So these are equal to 3. Fine. So resultant matrix will be 1 by 1 order, means we will be having 1 row and 1 column, means it will be having single entry. So let's write this 1 into 1. So it will be something like this will be multiplied with this column. So now let's do the multiplication. 1 into 1 plus 2 into 2 plus 3 into 3. So it will be having only one element, and the resultant matrix will be 1 row and 1 column, because one element will be single row and single column. 1 plus 4 plus 9, it will be 14, and it is of 1 by 1 order. Fine. Now we will calculate B A. We will write B first. So let's write B first. 1, 2, 3. Fine. And this is of order 3 by 1. Now write A. This is 1, 2, 3. Fine. So this is of order 1 by 3. Now you see the number of columns here and number of rows here are equal. So the multiplication is valid. Fine. And the resultant matrix will be of order, will be having 3 rows and 3 columns, will be of order 3 by 3. So it will be having 9 elements. So let me form the larger matrix. So let's do first row, this entry, it will be having 9 entries. So first entry, first row, first column. Fine. 1 into 1 is 1. Now first row, second column. 1 into 2 is 2. First row, third column. 1 into 3 is 3. Now first row is over. Now we will look at second row, first column. 2 into 1 is 2. Second row and second column. It will be 2 into 2 is 4. Second row, third column. 2 into 3 is 6. Now next we will be moving towards third row, first column. 3 into 1 is 3. Third row, second column. 3 into 2 is 6. And third row, third column. 3 into 3 is 9. So this is of order 3 by 3. So clearly AB is equal to 14 1 by 1 order matrix and BA is equal to 3. Therefore we have shown here that with example that AB need not to be equal to BA. So the matrix multiplication is not commutative. So that is how you carry out the matrix multiplication. So any matrix multiplication you can carry out and just write the result. So in case we are given 3 matrices and we need to multiply them like A, B and C, then we can associate them in any order and multiply, like we first multiply B and C, then multiply the result with A. Or we can also do one thing, multiply AB and then multiply it with C. So that we can do in any order. So this you can also check through any example, any valid example. So in this lecture we have studied the multiplication of matrices, that which rule should be governed while doing the multiplication of matrices, and that rule is that number of columns in first matrix should be equal to number of rows in the second matrix. Okay, so that rule must be followed, otherwise matrix multiplication is not defined, matrix multiplication will not be valid one. So that's all I have from this lecture, and I hope that I will be able to make you understand the concept of multiplication of matrices. Very soon I will be with you with my next video lecture. Till then, take care, bye bye and see you soon.